Welcome to The Explainer. Today, we're going to break down one of the most important stories in all of human history. And it all starts with a simple graph. It's the story of how, after thousands of years of going nowhere, we suddenly got rich. And, well, what that incredible growth has cost us.
Okay, so let's just jump right in with what might be the single most important chart in economics. Just look at this thing. For centuries, for millennia really, humanity was basically stuck. Living standards, what you might call GDP per capita, were completely flat. It was a low-growth trap. And then, boom, around the 1800s, everything changes. The curve just shoots straight up. It looks like a hockey stick.
And that right there, that's our big mystery for today. What on earth happened? Why did this explosion in prosperity happen so recently and so incredibly fast? And you know, this isn't just some dusty old history question. Understanding this takeoff is absolutely key to understanding the world we live in right now.
So, to figure this all out, we need to rewind a little and talk about a fundamental principle. Before we can get to how the Industrial Revolution lit the fuse, we first have to understand the basic engine that creates wealth in the first place.
Our first clue is a really powerful idea called comparative advantage. Now, it sounds a little technical, but the concept is actually beautiful in its simplicity. It's not about being the absolute best at doing something, it's about being the most efficient at it, compared to what else you could be doing with your time.
Let's make this real with a quick example. Meet Greta and Carlos. Now, if you look at the numbers, Greta is actually better at producing both apples and wheat. She has what's called an absolute advantage. But, and this is the key, Carlos is relatively less bad at producing apples. So what happens if they each specialize in what they're relatively best at and then trade? Well, the table shows it all. Their total combined production of both goods goes way up.
And that's the bottom line. The entire economic pie gets bigger for everyone involved. By specializing in trading, both Greta and Carlos end up with more apples and more wheat than they ever could have produced on their own. It's like magic, and it's the very first step on the ladder to prosperity.
Okay, so if trade and specialization make us all richer, it begs the question, why did humanity stay poor for so long? What took us thousands of years to get going? That brings us to the Great Escape.
This chart shows what historians call the Malthusian trap. For hundreds of years in Britain, anytime there was a small improvement in technology and wages went up a bit, the population would just grow, and that bigger population would consume all the extra resources, pushing wages right back down to where they started. It was a vicious cycle. But then, look right there, around 1800. For the first time in human history, both the population and real wages start to rise, and they just keep on rising together. The trap was finally broken.
So, the million-dollar question is, why Britain? Why then? I mean, historians have been debating this for decades. Was it the scientific revolution sparking new ideas? Was it a unique culture of hard work and innovation? Or was there something else going on? These are all really compelling theories.
But a really powerful explanation, and the one we're going to dig into, pulls together economics and global history. It suggests that Britain's escape was fueled by a very specific and unique set of circumstances, and they were deeply tied to its central role in a new global economy, an economy that was, frankly, built on colonialism and the slave trade.
And this slide just perfectly illustrates the impact. Think about it. To feed its growing industrial workforce and supply its booming textile factories, Britain needed cheap calories and cheap cotton. Trying to produce that stuff at home would have required a colossal amount of land, which would have made food prices skyrocket. But instead, it had access to vast quantities of cheap sugar and cotton from the Americas, produced by enslaved people. This access was an absolutely critical and often forgotten piece of the puzzle. But, you know, having access to cheap raw materials isn't quite enough. It's only half the story. You also need a powerful reason to invent new ways of using them. You need a strong economic incentive to innovate.
And that incentive has a name. Economists call it innovation rent. Basically, it's the jackpot. It's the extra profit you get to rake in by being the first person on the block with a new, game-changing, cost-cutting technology. It's the prize that drives the whole engine of capitalism.
So let's put ourselves in the shoes of a factory owner back in the 1700s. Your job is to produce 100 meters of cloth. And as you can see here, you've got options. You could go with technology A, which is super energy intensive. It uses just a few workers, but a ton of coal. Or you could use technology E, which is the exact opposite. Lots of workers, but very little coal. So which one do you pick? Well, the answer, of course, all comes down to the price tag. This line on the graph is what we call an isocost line. Think of it as your budget. It shows you all the different combinations of workers and coal you can buy for the same amount of money. To make the most profit, you just have to find the technology that sits on the lowest possible budget line. And at this point in time, with these prices, technology B is the clear winner. It's the most cost-effective way to get the job done.
Now, watch this. This is the magic moment. Let's say the cost of coal plummets, while workers' wages stay high, which is exactly what was happening in 18th century Britain. Look what happens to our budget line. It gets much, much steeper. All of a sudden, technology B is a terrible choice. The new, most profitable option is technology A, the one that saves on expensive labor by burning cheap coal. And right there, that's it. That's the massive financial incentive for someone to invent and adopt a machine that did exactly that. That is the birth of the Industrial Revolution.
And this isn't just a neat theory, by the way. The historical data totally backs it up. This chart shows that wages in England compared to the cost of energy and machines were way higher than in places like France. This unique economic environment created the perfect storm, the perfect cradle, for a labor-saving, energy-guzzling industrial revolution to be born.
So this explosion of innovation, driven by this very specific set of economic conditions, completely transformed our world. But it was all built on a foundation that came with a very heavy, very long-term price.
These two charts, side by side, they tell the whole story. On the left, you see the incredible payoff. As technology advanced, productivity soared, and after a bit of a delay, real wages for everyday people finally started to climb. That's the hockey stick of progress. But on the right, you see the cost. That growth was powered by burning fossil fuels, forging this direct, ironclad link between economic prosperity and carbon emissions, a link we are still trying to break today.
And our biggest challenge now is to finally snap that link. The goal is to keep the hockey stick of prosperity pointing up while bending that carbon curve sharply down. And the good news is, it is possible. Just look at countries like Sweden and France. They've shown that you can have incredibly high living standards that are compatible with low-carbon energy, mostly by using nuclear power and hydropower.
So, this brings us to a really crucial point. The recipe that made the first wave of countries rich, that specific brand of capitalism fueled by cheap carbon, it's simply not a recipe the rest of the world can follow without truly catastrophic consequences. We need a new path forward.
Which leaves us with what is probably the defining question of our generation. The first industrial revolution, the first great acceleration, was built on coal and steam. The next great leap in human progress will have to be built on something else entirely. The only question is, what?